Welcome everyone. So at this point we've been factoring for a while and we are pretty confident with it, at least I hope so. So what I want to do in this video and in the second video after this is just come up with make some observations and see if we can find some shortcuts / patterns, because there are times where you actually don't need to go through the entire generic rectangle process because you again have been doing it enough the way you recognize these shortcuts. Here is one of them, where I have 16x squared minus 25. So this is an example of a quadratic that is missing its bx term. But it's not that's missing, it's just invisible. So I could write it like this: 16x squared plus 0x minus 25. And so why do that? Well, the reason this is going to be helpful is because now I can actually use my generic rectangle process to factor it. So I'm going to set up my generic rectangle and I'll be right back. Okie doke. So here is my rectangle now. So I start off with my x squared term in one corner, my constant term, negative 25, in the opposite corner. Okay, so I need to figure out then what my two other diagonal boxes are going to have. So I need to multiply out to, well, 16 times negative 25 is negative 400. One way to do that is I like to think of 25 as representing 25 cents. And 16 would be the number of quarters I have. So 4 quarters make $1 or 100 cents. And so 16 means you have 4 sets of 4 quarters, which would mean $4 or 400 cents. Anyway, the next part here is that when I add these two x terms, remember I'm getting 0. So you have to exactly zero each other out. Okay. We've seen examples where you have to multiply and get to 0, and that uses our zero product property. We have not seen a lot of examples where, two numbers a plus b is equal to 0, or at least we haven't made a big deal out of it. This is actually going to come in handy right here, because if I know that two numbers add up to 0, I do know actually some very helpful information, that is that they are equal but opposite. So I can rewrite this as a equals negative b. Right? These two numbers, they're called additive inverses. So the additive inverse is just a fancy way of saying a number and it's negative, or the negative version of it. Additive inverses. The actual formal definition is that when you add them, you get to 0. But that really just means, for us, in this class, that's really just another way of saying a number plus its opposite. Okay, so normally I would write it as a times b gets me to negative 400, and a plus b equals 0. But since I know that a is really just the negative version of b, whatever b happens to be, I can just replace a with negative b here. Okay. Alrighty, so at this point, this is not really helpful because I don't know what that's going to be, because literally any number that b is, this would work here. But check this out. If I look at the product, I know that negative b times b is actually just negative b squared. And that's equal to negative 400. So this is something I can actually solve now. What I can do is I can divide both sides by a negative sign. So remember that this is really negative 1 times b because of order operations. And so I could divide both sides by negative 1, and I'll get b squared is equal to 400. And so b is just equal to the square root of 400. If handed down the calculator, we can see that that is actually 20. Okay. So what have we shown at this point? Well, we've shown that my two numbers a and b are 20, and remember a is the negative version of that, and negative 20. And so one of these boxes is going to be negative 20x, and the other one's going to be positive 20x. And again, now we have done the hard part. And so let's just finish this off now. I'm going to look in here at the top row. Well, let's see, a common factor from 16x squared and 20x. Well, I can see an x in both of them. And I also see a 4 in both of them. So I'm going to pull out a 4 as well. Sorry, that's negative 20 here. If I could look at the first column, I get the same thing actually. 4x, 4 goes into 16 and 20, and x goes into x squared and x. We get a little bit more interesting when we go on to the next column here, because 4x times what gets you to negative 20, and that's going to negative 20x, and that's going to be negative 5, so plus negative 5 there. And down here, negative 5 times what gets you to negative 25 has to be positive 5. And so we get this interesting pattern where this factors into 4x minus 5 and 4x plus 5. Okay? And this is actually always going to happen when we have something like this. So what makes this one so special? Well, we notice two things here. Well, one is that the bx term is equal to 0x because it wasn't there. Right? We didn't see it. There was no bx term to start. So that's important. Our sum is only an x squared term and a constant term. We also notice is that these two boxes came out equal and opposite as additive inverses. This happens when we notice the terms in the factored form in the factors and in the sum. Check this out. When I look at 4x and 4x, well, 4x squared, again, that whole thing, 4x squared is equal to 16x squared. And notice here, when I check out 5 and 25, 5 squared is equal to negative 25. And so what we actually have here, and this actually has a name, it's called a difference of squares. And notice that also because the signs are opposite here, the signs are opposite here. So this is what a difference of squares is, and we kind of notice this shortcut. A difference of squares. So a difference of squares is anything that you have that looks like this, or you have a squared, where a is just some number, but this is a perfect square. X squared minus b squared. Okay. In our example, we had 16x squared minus 25. So I could rewrite this as, 4 squared x squared minus 5 squared. And so this will always factor into something like this. And notice here, we had 4x minus 5, 4x plus 5. This is always going to end up being ax minus b, ax plus b. Again, just based on what we have been doing. An exercise that I would recommend to you is to just use a generic rectangle to factor this and prove or show that you will actually get here. Okay. Thanks for watching. Hopefully this helps, and hopefully you can see that little shortcut, and I'll see you in the next video.